Hello, everyone. So today we are going to start another project which we are going to use for the exploratory data analysis, and further we can create a machine learning model as well. So the data that I have used is the the data which is there from the job portal, which is Glassdoor. So on my screen, you can see that we have so many columns available into this. Let me scroll it to the bit starting. We have job title, we have salary estimate, we have job description, we have rating, company, location, headquarter, size, founded, the type of ownership that particular company do have, industry, and the sector that that particular company is working for, which sector, and the total revenue. And we have that revenue in the the range we have, and we can see that there is so many scope for the data cleaning part. And here, if I scroll it a bit to the revenue, we see that we have to remove those the cleaning is required. We have some specific the things that should be removed and that required cleaning. And if we go ahead with this first column, the data scientist one and the salary estimate that we do have, that's kind of an object column. So we required to, clean this as well. And if we see that the size of the company, that is also into the range. So that is no proper formatting, the same formatting to the entire data. That's what we can see. We have two as a range between these, the starting point and the end point. And we have like 10,000 plus employees are available in that company, something like that. And type of ownership, we see that there are 3-4 type of unique records are available, like public, private, or NGO, or hospital, or something like that. So that's what we can see. And for this competitor, so for this competitor, I have noticed that there is some numeric value was there that should not be there. But once I filter that, and I see that so many records are there with this -1 value as a competitor. So we have to deal with this situation as well, that how we're going to, if we drop it, so we are going to remove so many rows just because of having this -1 value, which is, so either we can rename it or we can give it a different label. So that's what we can do. So this is the data set. And now I'm just going to open my Jupyter to start with. Okay, so yes, so here it goes. So the data set basically is for from the job portal, where we do have different columns that we need to understand. And based on that, we have to do certain analysis. So the data set, let me open. Okay. And further, we can use it as a machine learning approach, where we can predict the salary of the data scientist, something like that. And the data set is here. I have already created a Python notebook, so I'm going to utilize it so that we don't waste time while writing code. So better I'll explain rather than writing this stuff and all. So here we're going to import the required libraries, and that one is the NumPy and the pandas. And then I'm going to read this CSV file. So once I read it, let me open it as a head. These are some basic stuffs, and we see that we have one unnamed column as well. We can remove it later. And this is the data set that we have. And now we are going to explore it. So, we are going to check that how many total rows we have. We have 956 rows and total 15 columns. So small data set that we can, easily understand. And these are the total columns that we do have. And just to check the data types, I have noticed that we have so many object column, and there are 2-3 columns, unnamed, that somehow we have to remove. And the float is the rating, and the founded as the integer column. So this is what we observed. I already did a head, and tell you all know that just to get the last 5 records. And here we have put it the info. Info is basically just to get the idea of, the basic information of your data set. And further, describe that we can use for the statistics purpose, and we did the transpose into it. So either we can remove that column. I think we should remove it. Or what we can do here. Okay, just give me a moment. Let me remove it from here only. Okay. So here it goes. I think it's going to take some time. Otherwise, using pandas, we can also drop it. But that file was already open, so I just deleted that particular column. I think it's taking a bit time. Meanwhile, let's go through with that. Okay, so that doesn't make any sense. So either we can drop it. Let me drop it here only. How we drop it? df.drop, and the columns equals to, and the name of the column is unnamed 0. We can simply copy and paste it. Okay. Yeah, that is not there, but to remove it, actually we need to use in place equals to 2. Right. So we are good to go. So we remove that unnecessary column now. And we see that basically we have the statistic summary that we can show for the numeric columns only. And we identified there were 2 numeric columns. One was the rating and the founded. So we can see that is the total count. And from this count, we understand there's no missing into the rating and founded column, because what was the shape of your data? The shape of the data was 956 only. So here only we can see that there is no missing records in these 2 columns. And that is the average and the standard deviation, and that is the mean, minimum, not mean, and the lower upper quartile, and the median, and the maximum value of these 2 columns. And now in next, what we are going to check whether we do have some missing records to this data set or not. And luckily there is no missing record. All the values we see that false, and we can do one more thing. Let me write that here only. So we can do df.isNull.sum. So we can check the count of missing records. So rather than having Boolean value, we can check whether we have some missing or not. So there is no missing. All the sum for all the columns is 0. So here, because we have already basically dropped that column, so that is not required. But there is another way to do it. We can simply pass the label or the columns. If we pass the column, so access, we don't need to write it. So I already used that part, so there is no need to, let me comment it. So here are the columns. We don't have the unnamed one. Now, basically salary estimate, where our salary estimate is not equal to -1. So because we observed that there was one value which is like -1 as a salary estimate. Let me showcase you. Okay. Let me do it that way only. Okay, here is the data set. So you must notice that there was one value as -1 into the estimate salary. You see this one, -1 was there to the row number 26. So what we are going to do it, we need to handle it. So we are going to check that how many values are there where we do have, we don't have salary estimate column not equal to -1. So before checking this, we check the shape, and after that we check the shape. So we see that there are total 956 records, and out of 956, 742 where we do have value which is not equal to -1 in salary estimate. Rest is we may have different values. So this is what the observation. Now what we can do, Basically, we are going to remove the text column from the salary estimate text value from this salary estimate column. So we are going to do it using a lambda function. So let's do it. I mean, what we are going to do it. This is the basic function. Let me run it. How we use it. And this is the function that we have created. Let me explain that as well. This particular function is doing what? So let me give it a name, basically test. Okay. So we have to call test. So in test, in case we pass some value, what was the value in salary estimate? So any value we can pass, something like this. So let me put it there. Oh, not in code only, right? So we run it. No, we don't need to. This was there and this was there. So it was the part of this only. So let me put that into double quotes. Here it goes and here it goes. Fine. So we see that we have removed that text value, that extra test value, which was there, which was starting from the open parenthesis, and the quotes was there, and we have picked the zero index. So that is going to be considered as a zero index. Let's say if we pass one index, so what we are going to have, we are going to have this one. So we are going to split it from here. And the first part is this and the second one is this, but we needed the first one. So we are going to remove glass door estimation, something like that. So that's why we have passed 0. Okay. So here we have into that particular salary value, we have all the records as in the form of dollar symbol and the K as a I mean, how to check it, the 53K to 91K value, something like that. We remove the text data from that column. So this is what we did. Now we are going to replace all the dollar symbol. We are going to do it step by step so that you guys can easily understand. We are going to remove the dollar symbol and the K value, which is there. So these two things are there as an object, and you can take it as a special, as an extra character, so that we can later convert that into the numeric value. And to do that, we have created a lambda function. So what this lambda function is doing, whatever value you pass to it, it will replace all the dollar symbol as a empty string, and then replace all the K value as an empty string. So we have removed all the K and all the dollar symbol. Only the hyphen symbol is there. So this is what we did. We have to run that salary as well. We haven't run that. Here it goes. So we removed it. We see that it looks much better than the previous stage. Previously, that column was looking something like this. You see, something like this. So in first step, we removed it. And in second step, we removed the dollar symbol and the K. And now we have to look into it that what else we can do. Okay, so this is here. Now, basically, we need to check that what is how many total unique records are there in the salary data set. So salary column. So in this salary column, we have applied a unique function, and then we check the length so that we can check the total unique records are there in this column. And then from the unique, we have put it all after 380. So we just run it. So randomly, we just check it out. You can take any value. Let's say the length was 416. So you keep checking after, let's say 4,400. So these are the records. Just to get the idea that how this the distribution of the salary column is there. Now, okay, so these are the range that we do have. Let me pass it for 380, and we see that the variation is there. Okay, so that was the observation. And one thing that we notice that here is something that we can see, and we can see that per hour value was also there for all the unique records. We find out this thing, and these texts are still available. So we are going to create a one column as a a salary per hour, where if that value is there as a per hour, because that range of salaries, sometime we get that salary monthly and sometime it's for per hour. So we need to check it out, because we were just having that record as per hour, so we need to make it as per month or something like that. So either we can convert all the records as per hour, or we can make per hour to the month. So it's up to you how you want to do it. So we have created a one column for per hour, and we have used, if we do have a value like per hour, then we'll convert it. So we make it as true, as false, and then we applied value count to this column. Let me run that as well. And then we see that we have 24 true values. That means total 24 records are there where we do have record, the salary in terms of per hour. Rest 718 are there where we don't have that text per hour. So that is something we observe. One thing we noticed while we were doing, we were checking the unique record into the salary column, that was employer provided salary. So that is also a text that we need to clean. So we again created a lambda function, and we checked that if we found this text anywhere, so make it true. Rest we are going to make that particular record as false. So we applied it, and we again check the value count, and we see that there are 17 records are there with employee provided salary. So that's what we observed, that is still we have two textual records in the salary data. So we are going to remove this per hour employee provided salary from this salary column. So how we are going to do it? We are going to apply a lambda function, and we are going to lower it. And wherever we find per hour, we are going to replace it as a empty value. We are not passing anything. And wherever we pass employee provided salary, that is also going to be removed, and replace all these spaces with no space value. That's what we are going to do it. And then after applying it, we again check that some either we remove the per hour or employee provided salary from this salary column or not. And previously, where we noticed after 380, I think there was, after 380 we got it that there was some data errors, I could say, or some inconsistency in the data was there for salary column. And we again cross verified it after removing all the textual values, and we see that we're done with that part. We don't have any text available in this column now. The per hour text or the employer provided salary text is not there. So let's move to the another column. We are going to create a new column where we are going to have basically that salary was there in range. So the first range is obviously the minimum salary, and the last range that is separated by hyphen, that is the maximum salary. So what we can do, we can create two columns. So rather than putting it as a salary column, we take first part, whatever we have before this hyphen, as a min salary, and whatever we have as a last element to this as a maximum salary. That is something like we can do. So we have created the min salary column, and we applied a lambda function. We split it, and we split it on the hyphen, and we have taken the 0 index, so that we can have all the starting range of the salary into the minimum underscore salary column. So these are few values that we have generated. I just showcased bottom 5 only. You can try with head and other indexing too. And the same we did for the max salary, where we are going to take us one index, because after splitting that with hyphen, so 0 index goes as min and the 1 index goes as max. So here it is. So now, as we have created a min salary and a max salary column, now we don't require basically the salary column, I think. So one thing, that's what we can do, because min salary and max salary we have created from that salary column only. So we can calculate the average salary as well. How we are going to calculate it? We can add min and max salary, and we can divide it with 2 so that we can get average salary column as well. So this is what we did here. These are just the techniques or the analysis things that I applied. You may try a different approach too. So what we are going to do it here. So converting the hourly salary to annual salary, because we noticed that there was one column where we were having salary as a per hour. So we are going to convert that as an annual salary. So to do this, what we did, salary per hour, we have applied a lambda function. So wherever for this min salary column, if we get salary per hour, so basically we are multiplying it with this value, or we are storing it to this minimum salary column, whatever we are having to as a, the hourly salary into this particular min salary column, and we are going to convert it. And the same thing we can do for the max salary part, because the per hour was there for min and max both. So this is what we did. So this is, and again, we have extracted all the values where we have salary per hour equals, the value of salary per hour is 2, or the salary per hour equals to 1. And we have extracted the salary per hour with minimum and maximum salary range. So for 1 hour, we have extracted just to see, and we see that we have salary per hour. 1 hour, we see that minimum salary is 17 and the maximum is 24. So maybe that is in dollar or in any currency. We see that for per hour salary, minimum per hour salary is 17 and the maximum is 24. So something like that we can observe from these records. And these are the variations that we found for per hour salary range, the min and max that we see. There is not so much variation into the data, but still we see some value as 39 and 34 is also there, and we see 47 is also there, and to the minimum direction we see 10 is also there. So something like that we can observe. Now we have a company column. So let me call the DF here so that you can get the idea. We see that we have a company name column, and then here we are going to apply that we have some backward slash n values are put it there into that company. So these are some, we can see that some irrelevant data is there. So that text we can remove. So we have applied the lambda function, and we are going to remove that extra text, and then we are extracting the 0 index from there. So this is what we did. So we find it out something like this. So that company name is also much better now. And again, we have created a column where we have, the location. And for that location, you see that, let me showcase you the location column. Here it goes. So in location, we see that we have some, you can say the city, or we have some state, something like that. So anything which is separated by comma, you can consider that as a state. Not consider, that is going to have a state value only. I do not remember the name of all the states, but this is what you simply Google it out and you can check that whether we do have this state or not. So from the location, we have split the data from comma, and anything which is coming as a 1 index, we have extracted that part from location column, and we have put it that into a new column so that we can have the job state column as well. So this is what we did here. I have applied a lot of lambda function here so that you can, you also learn that might be in different data set, you may have similar kind of problem to solve. So you can utilize it there too. And this is how we have created a job state column, and all the state has been extracted from that location column. And now we are going to check the total unique records that we do have for job state. Let me run it as well. So these are the total states that we do have. And for that, one thing that I noticed, there is one state where we don't have the short names. You also notice it. For all the states, we have short names, but for Los Angeles, we don't have the short names. So that's what we can convert simply, right? So what we can do, we can, going to convert it as a CA. I mean, that's what we can see. California, we can make it. And this is what we did here. We find out where we don't have anything which is Los Angeles, and we are going to strip it and convert it into the lower string. And then from the job state column, we have extracted and store it again to the job state. And this is what we extracted. And if we apply a value count directly, you can see all the job states are there, right? This is what we did here. So we remove, apart from the Los Angeles, we put all the states as it is, and wherever we find Los Angeles, we converted that as a C. So this is what we did here. Now let's move further. Again, the job state, just to cross check, we see there is no, the long name is there. We have converted that as a short name. Now we are going to check the A's of the companies. So company A's, we are going to check from the founded, and basically what we are going to extract that if we have any, company which is founded, basically what we are doing, the total number of years we are calculating from the current year. So we can use 2022 here. And so this is the current, from the current year. And this is from the founded, we have, if we see the date value to the founded here, let me showcase you. For the founded, we see that the founded year has been put it there. So from that date to the current year, we are going to calculate the total number of years. So this is what we did here, right? So these are the, from the founded column, we have created a new column, which is company A's, and we have put it everything from the founded to the company A's. So you notice that we have created a new column based on the existing column. So might be we don't require those columns, so we may remove those later, or if we require, we can have those. So now the further, what we are going to do, let me again call the data frame. We see that we have a, job description column. Let me basically showcase you that one only. This is the column. Okay. Here it goes. So we see that there are few things that we noticed into the job description. Few keywords must be there. Let me put it as 0 index. So we see this is the entire job description, and from the job description, you can see the first thing that they have put is the profile, or you can say the job profile, and the location, and then the education, and then we see that some skills required, all the skills they have put it. So few things that we have, and we all know what exactly the KRA that is given. So that is kind of a para that we have to each and every record under job description column. So we need to extract some specific keywords from there. So what we are going to do, if we find Python, RStudio, Spark, AWS, Excel anywhere in the job description, so we are going to categorize the job description column, and we are putting all the jobs which is related to Python, R, Spark, or AWS, or Excel, you can say. So that what I did, some filtering based on this Excel. So that's what you can do. You simply go to the job description, you apply the filter here, and we see, you can see the total number of records. So these some basic level of understanding you can have from this Excel only, that you need to go through to understand it, to get the more in-depth idea. So That was my observation, that if from the specific programming language or the tool, the keywords that we can extract, and we can create a new column based on this, so that we can separate all the jobs based on the skill set or the programming that you can say. So from this job description, we are extracting the Python job, R job, Spark job, AWS job, and the Excel job, so that we can have, the separate, the columns for the every language, you can say, or the tool. So this is what we did here. Then for the Python job, let's do the value count, and we see for the Python we have total, the value that we do have, we have 392 and 350. So these are the total records we have. 0 and 1 we have. Basically, if we have Python in the job description, we have put it as 1. If we don't have Python, then we have put it as 0. So we see that 392 job descriptions are there where we have Python keyword. And the same goes for RStudio. So we check that. Let me check for RStudio as well. So we have total 1 record. For R, there is only 1 true value. And for Spark job, we have basically the majority is into the Python. I could see the Python, there was 392, and for the true value was 392, and for R there was single value, and for Spark there was 167, and for AWS, if we see, there was 176. And again we can check it for Excel. So you can do it at this part in one go. We can create one user defined function, and we can basically rather than doing this part into the multiple line of code, you can automate this as well. So I just wanted to showcase you, so that's what I did. So this is the data set that we have created till now. Now we see all the columns. We have job title, we have salary estimate. We haven't made any change, I think. No, we have created a new column basically from the salary, that was the min salary and the max salary. So we may drop some columns from there that we utilize for creating new columns, right? So these are the columns. Now, the job title that we can see, we have data scientist, healthcare data scientist, some more long keywords we have into this job title column. We see that if we apply a value count, we can check it out that the majority of the records are there for the data scientist, I think, and we do have some data engineers and some data analysts and some senior profiles, some lead as well, some associates as well, something like that we do have, right? So we are going to simplify this, so that for the title column, we have created a small function. In that function, if we find anything as a data scientist, so we return as a data scientist only, and same we did for data engineer, analyst. Into the entire title, we are going to check basically. And basically whatever we have as a long title, so we are putting it as a single word. And apart from this, we have considered only data scientist, data engineer, analyst, machine learning, manager, and the director. Apart from this, everything we have put it as an NA. So this is how we are going to simplify the job title basically. So we are going to create a new job title simplified column using the existing job title column, and after applying this title simplifier user defined function that we have created here. So let me run it, and then we again apply a value count. So we see we have total for 279 records out there, apart with 900 something records. That data scientist keyword was there for 279 times, and the data engineer was there for 119 times, and the director and NA value was there also for 184 times, right? So machine learning engineer also, because we have put it that as MLE, so you can give any name, right? So now again, because we also having one call, we are going to put it as a seniority. Again, we have created a seniority column. If we find any something like senior in the title, or senior in the title, or lead in the title, so we are putting everything SR senior or SR lead, something like that. We are going to make it senior only. So anything which is junior dot or something like that, we are going to return it as a JR. and rest we have put it as NA. So we are going to create a job seniority column where using job title, we are going to convert all the senior, junior prefixes, you could say, as a senior and junior only, and rest we are going to take it as a NA. So we have basically simplified it into the 3 categories. So we have 520 records as NA and 220 as senior, and there is very less record we found it as a junior. So now one more thing that we have, the data we see that there was, I was discussing in the starting of, that there was a column, the competitors. Into that we were having that -1 value. That should not be there because all the value was there as a text, but we found that as -1 as well. So we are cleaning that competitors column as well. So we have applied a function where we split that on comma, and if we have a value which is not equal to -1, so then we applied that to the competitor, and then we are going to convert it as that value, and otherwise we are going to convert it as 0. So this is something we have put it out. So we check it out, and we basically if we apply the value count to this, means so many records we may check for this competitor column. So we did a bit cleaning into that. So again we check the cleaning for the let me apply it here. What is the issue? So for the competitor, that is a int object basically. Let me check the data type. .datatypes. So we see that competitor column was there. So that is an integer value. And for that competitor column, I think we have to convert that as a string. So that's what you can do. You can convert that as a string. That is not a string for now. S type str, we can use it. And then we can apply this split function and all. So this is what you can do. I have just given you as your practice. Now again, go to the type of ownership column. For the type of ownership, we see that the private company, the public, the non-profit organization, college, university, something like that we do have as a the type of ownership. So what we are going to do it, we are going to simplify it basically. So whatever we have as a private in the text, whatever they have written as like either company private or the any other keyword they may have as a private in the title. So that we are going to take it as a private, LF public, or let's say anything which is found the unknown. So we are going to put it as other organization. Otherwise the text will return as it is. So for the type of ownership, we have created this, and here it goes. So we have put it private, public, and what else we did, and there was, we check that for private and public only. So unknown we have put it. So there is no unknown. I can see there is no unknown, right? And we have college, university, other organization, hospital, government, something like that we do have, right? So again, what we can do, we have to do the cleaning of revenue column as well. For revenue, I told you there was a lot of text value was there. Something was in range, something with the plus value, and amount was there in for billion, million, and the less than, some different categories was there. So we need to clean that too. So to clean it, if we have -1 in text, anything might be -1 value was there. So we need to remove it. We can directly remove it. So we can make it unknown or non-applicable. Else we are going to return the, for this function, we are just solving this part. We can drop that row too. So might be here we have less data. So there is one record only. So we can drop. Might be we have so many records, so we don't want to drop it. So we can simplify that part. So we can make it like unknown or non-applicable. So then here it goes the revenue column, and we see that -1 has been removed, and we put it as unknown and known applicable, something like that, right? So there was how many total records was there? Right. So -1 also we put it as a to this category, unknown and known applicable. Previously it was 203, now it has become 204. So I mean, next what we can do, we minimized one category from this. For the size column, we see that we have range, we have plus, so we need to do some data cleaning to the size column as well. So first we removed, first we clean that -1 stuff, so we make it as unknown, and we return all the values as it is. So here it goes. So we basically converted this part only. So here is the data set till now. Let me pass to. So we see so many columns that we have created. So previously it was, I think 14 columns was there, and not 14, I think more than that was there. Let me check. So previously there was, okay, 14 column was there. Now we have total 18 columns. So we basically create extra 14 columns out of this existing data, right? So we solve the revenue, we solve the size as well, and this is the data till now. Now we need to do the data cleaning that we done till now. We have to do the EDA part. So I hope you're done with the data cleaning. So we are going to explain the EDA stuff to the next video. Meanwhile, you just go through with it. You try other approaches too. Might be you get something different to apply, and you may have a different idea to solve it. So feel free to connect or write into the comment box if you are solving it in another way, and if you find any difficulty, so you feel free to connect. And that's it for today, and I'll continue with the next session. Thank you everyone. Take care. Bye bye.